Hi, welcome to Environmental Management. Today's lecture is on adaptive resource management process. Adaptive management is a process that we use whereby we learn through doing and then adapting our management strategies based on what we learn. Basically, our management actions are small experiments that is based on meeting science-based credible alternatives for natural resource management. The process has been widely used by the Department of the Interior and actively involves stakeholders that will share in the outcomes of the process. Adaptive management provides a clear record of the decision-making events. So structured decision-making is an organized approach to identifying and evaluating creative alternatives and making defensible choices in difficult decision situations. Typically, these difficult decision situations can include controversial topics, management needs that have no prior understanding, or decisions that are made on an annual basis. One of the primary adaptive resource management approaches is known as strategic habitat conservation. Strategic habitat conservation is a unified approach for defining and pursuing landscape and population sustainability. This is a structured science-based framework based on adaptive, iterative process. The fundamental core of strategic habitat conservation is the need for consistent approach to set priorities and to develop goals and objectives. Its primary focus is the need for landscape and population sustainability. Strategic habitat conservation has 5 essential framework functional elements. These include biological planning, conservation design, conservation delivery, decision-based monitoring, and assumption-driven research. So let's look at the basic framework. 5 functional elements form a circle. At the core of the process is the need for effective communication, setting priority species, formulating population objectives, and synthesizing scientific models. The process is adaptive in that specific questions are addressed so that answers are determined and used for management decisions. Based on those answers, the process is either repeated, thus iterative, or new questions are asked and the process repeats again. In the planning phase, there are basically 3 different kinds of planning: biological planning, conservation design, and programmatic planning. As the name implies, the U.S. Fish and Wildlife Service uses strategic habitat conservation as part of their program. It's used in the strategic planning for the Partners for Fish and Wildlife program. It's also used to make decisions for the Migratory Birds program, and it's also used for cooperative conservation programs at national wildlife refuges. During the biological planning phase, there's a set of basic blocks that are determined which guide the rest of the process. This includes a transparent, replicable process and procedure that's used to derive the specific conservation objectives. These objectives have specific measurable biological outcomes. During this phase, priority species are selected. Sometimes a subset of these priority species are considered focal species. Next, we look at determining population objectives. We assess current population numbers and their status are measured. Limiting factors controlling population numbers are identified, and models of habitat relationships are compiled and applied. The conservation design phase is based on spatially explicit conservation priorities for a region or area, and the spatially explicit conservation planning applications that are used to decision to support tools. Based on the flowchart, you can see that species models are populated with current collected status and abundance information. On the population, this is then combined and used to identify specific priority areas critical to the species' success and to specifically formulate habitat objectives. Conservation delivery includes implementation of on-the-ground actions that is based on information from biological planning and conservation design. It includes identifying potential pilot studies that are used to identify the best location and best actions to make the best decisions. Experiments are established on the ground so that measurable differences in biological outcomes can be determined so that we can be sure that we are making the best decision in our actions. Perhaps most important aspect of the establishment of partnerships. These are used to enhance the effectiveness of the actions on the ground. We refer to this as a synergistic relationship since it magnifies the abilities of any one individual group in achieving much more. Decision-based monitoring is used to formulate the data collection and use that information to determine additional research needs and to increase the certainty associated with the decision. This, in turn, is used to make the management decision so that the information is specific and targeted for the organism and original assumption-driven questions. Monitoring required for this process is more than just tracking program-centric accomplishments, but rather evaluates resource-centric outcomes at multiple spatial scales. By monitoring biological outcomes, stronger decision-making is accomplished by learning and structuring linkages to direct measurement and data acquisition. At the heart of this success is monitoring biological outcomes at broad spatial scales. This cannot be done alone or by a single group. Rather, it requires interagency and stakeholder collaboration. This brings us back to the original biological planning phase. At this point, process and progress towards the population objectives are evaluated to see if additional scientific information is needed or if the stated objective has been accomplished. Based on that decision, the adaptive process of learning from the results obtained is assessed. If accomplished, additional evaluation is conducted for the next annual cycle to make the repeated measure decision. However, if more questions are raised from the assumption-based research, then additional objectives are determined to support the original population goals. In summary, the nature of our conservation management is changing. Better tools are needed to address the management science associated with our response to change. Large landscape factors such as climate change, sea level rise, land use conversion, and restoration all require adaptive processes to succeed. Functional elements of strategic habitat conservation are applied to the region or specific landscape scale with a focus on trust resource sustainability. This is done in partnership so that public lands, migratory species, and interjurisdictional species, which are all trust resources, are properly managed. The approach is based on sound science principles with conservation target focused on landscape and population sustainability. Thank you for the opportunity to present this information today on adaptive resource management. I hope you've learned a little bit more about it and also about its primary use in strategic habitat conservation. Thank you.